On November 20th, the James Webb Space Telescope unexpectedly detected signs of life inside ThreeI Atlast. This object had already left the scientific community perplexed, a hyperbolic orbit with unusually precise parameters, CO2 that was too clean, almost no water, no typical coma. James Webb then recorded light pulses repeating in a sequence of prime numbers, exactly like a structured optical code. As the hypothesis of a spacecraft disguised in a comet shell spread, the defense sector immediately stepped in, and the X-37B quietly changed its orbit to shadow it. Meanwhile, NASA's official images of Atlast were blurry with contradictory tail directions, while the images from amateur astronomers were sharp and consistent, revealing a vivid plasma halo surrounding ThreeI Atlast. From there, the plasma bioform hypothesis emerged, moving in parallel with Avi Loeb's technology hypothesis, and directly confronting the mainstream evidence from Hubble SphereX and Meerkat data that could still fully explain Atlast as an interstellar comet rich in ice and familiar chemistry. But the mysteries of ThreeI Atlast are gradually coming to light. We are about to enter a new journey where James Webb will not only see light but see life, and where NASA begins to put forward bold predictions about what is about to happen with ThreeI Atlast and with our own civilization. At first it looked like a comet, faint and unremarkable, a cold traveller reflecting the sun's light as countless others had done. But as the data streamed in, the curves of its path broke the rhythm astronomers knew by heart. ThreeI Atlast was not behaving like ice and dust. Its trajectory was precise, almost rehearsed, slicing through the solar plane, with a velocity that defied ordinary gravitational capture. When the system plotted the orbit, the return showed a near hyperbolic escape line, as if ThreeI Atlast were arriving, performing and leaving by design. So the James Webb Space Telescope was tasked with a closer look, peeling back the glow around ThreeI Atlast in infrared. Inside the hollow shadow of the traveller, Webb found something no one had expected: layered pockets of complex chemistry, pulsing in step with the light spectral signatures that matched not frozen stone but active metabolism. In the darkness beneath the dust and CO2 shell of ThreeI Atlast, there were patterns of heat and molecules rising and falling together like a heartbeat. The first quiet hint that this visitor was not just carrying matter between stars but carrying life itself. For days, radio chatter between observatories carried a tone of disbelief. If it lacked ice, what fueled the glow? If it lacked tail, what refracted the sunlight? Some proposed a dust-coated asteroid heated by solar flux. Others whispered of metallic reflectivity. Then came the first anomaly report, a minute rhythmic brightening every 47 seconds. The signal repeated, unwavering across wavelengths. Instrumentation confirmed it was not noise, not a flicker from the detectors. ThreeI Atlast was pulsing. At the time, no one dared to label it deliberate. They called it a rotational modulation, a safe phrase for a strange truth. But when the James Webb Space Telescope aligned for observation, its sensors registered coherence patterns inside the pulse's harmonics that hinted at structure, not chaos. Suddenly, the discovery felt heavier. The community fell silent for a moment too long, that shared pause when curiosity meets unease. ThreeI Atlast continued forward, silent and steady, like a messenger unaware of the noise it had created behind it. Every few hours it brightened again, marking distance like a heartbeat. No tail, no coma, no comfort of familiarity. Only motion, exact, intentional, patient. Somewhere between datasheets and speculation, a realization took hold. ThreeI Atlast was not simply passing through. It was revealing how little we understood about what passing through even meant. When the James Webb Space Telescope finally turned toward ThreeI Atlast, the expectation was routine. Observers anticipated a faint, featureless point, the quiet glow of a small body passing through sunlight. Instead, the raw data from ThreeI Atlast arrived with a subtle repeating rhythm, like a distant beacon rising and falling behind the noise. At first, analysts thought the pattern from ThreeI Atlast was an artifact, a quirk of the detector or software. They checked the instruments. They reprocessed the frames. The signal from ThreeI Atlast was still there. Buried in the integrated light from the central region, a gentle brightening appeared and faded at regular intervals. The luminosity from ThreeI Atlast rose, held steady for a breath, and then dropped away again, only to return with the same spacing as before. Across multiple observations, through different filters and exposure times, the cadence of ThreeI Atlast remained unchanged. When they plotted the brightness curve, the line from ThreeI Atlast looked almost mechanical. Each pulse was separated by the same span of time, each crest nearly the same height. Noise and cosmic rays were messy, random, impatient. ThreeI Atlast, by contrast, seemed patient, measured, unhurried. That regularity caught the attention of the team, and they began to treat the light from ThreeI Atlast not just as glow, but as a possible signal. A spectral analysis followed. They decomposed the flicker from ThreeI Atlast into frequencies peeling back layers the human eye could not see. Within the main rhythm, the detectors around ThreeI Atlast revealed higher harmonics, faint overtones stacked like steps above the bass note. Natural sources could produce structure, but the pattern from ThreeI Atlast had a clarity that felt engineered like chords, arranged instead of noise accumulating. Someone suggested rotation, a tumbling shape turning reflective surfaces toward and away from the telescope. But rotational light curves drift, warp, and respond to changing angles. The pulses from ThreeI Atlast held to their timing with remarkable discipline, even as the geometry between Earth-Sun and the path of ThreeI Atlast slowly changed. The spacing between peaks barely shifted. The object behaved as if an internal clock, not an external glare, was in command. Around control rooms and late-night offices, a quiet thought began to surface. What if the brightness of ThreeI Atlast was not just illumination but punctuation? What if each rise and fall from ThreeI Atlast was part of a sequence more like a line of text than a random flicker? No one wrote that into the official reports, not yet. On the record, the teams described a coherent optical modulation associated with the interstellar visitor. Off the record, they spoke in softer tones in the hush, reserved for fragile ideas. Atlas seemed to be speaking only in light, soft, regular, and indifferent to whether anyone was listening. The next step would be to follow the path of ThreeI Atlast more closely to see whether the motion matched the mystery in the pulses. If the light from ThreeI Atlast was encoded, then a quiet question followed in every control room. If ThreeI Atlast was sending something outward, who or what was meant to receive it? Behind those doors, attention shifted from the signal itself to the path that carried ThreeI Atlast into our neighbourhood. Trajectory charts began to fill screens. When astronomers reconstructed the orbit of ThreeI Atlast from early measurements, the numbers outlined not a bound ellipse but a sweeping hyperbola, diving in from far beyond the sun's influence. ThreeI Atlast was moving too fast to be captured on a one-time passage through the system, a brief visit carved into gravity's fabric and then gone. What startled the teams was not just the shape of the path, but how precisely ThreeI Atlast threaded its way through the inner system. Plotted against the spread of observatories, Earth orbit, lunar orbit, Mars orbit, Lagrange points the line of ThreeI Atlast curved through a corridor where almost every major eye could in principle watch. 3. Atlast brushed just close enough to favoured long baseline instruments, skirted near fields used for deep surveys, and crossed regions already crowded with sensors. The orbit of ThreeI Atlast looked less like a random throw of a stone, and more like a tour through vantage points. Size estimates added another layer of unease. From brightness and distance, the core of ThreeI Atlast appeared to span tens of kilometres, far larger than known interstellar visitors, and on the upper edge of what models expected to survive ejection from a distant system. ThreeI Atlast was not a small shard adrift between stars. Atlast was closer in scale to a minor world, a compact mountain of material that had somehow been flung into interstellar space and then aimed with surprising precision. Then the dynamics team noticed something else. When they fit the motion of ThreeI Atlast with pure gravity from the sun and planets, the path almost matched but not perfectly. The residuals were small, a whisper inside the noise, yet persistent. As ThreeI Atlast drew nearer to the sun, there was a faint suggestion of braking, a slight slowing, that did not fully align with ordinary models of dust drag or outgassing. They added solar radiation pressure. They added hypothetical jets of gas from the surface of ThreeI Atlast, even though telescopes still failed to find a conventional coma. The mismatch shrank but never vanished. ThreeI Atlast moved as though some gentle hand were adjusting its speed, not enough to shock the equations, just enough to trouble them. For some, the anomaly of ThreeI Atlast remained a statistical curiosity. For others, it felt like intent hiding inside orbital elements, a kind of quiet steering disguised as imperfection. As the path of ThreeI Atlast carried the object deeper into that corridor of visibility, a new idea began to crystallize in the background. If ThreeI Atlast was not shaped like a normal comet, perhaps ThreeI Atlast had never been only surface and stone at all. Among the theories that began to take shape, one in particular refused to fade. If the behaviour of ThreeI Atlast seemed engineered, perhaps its very body was part of that design. Across internal discussion boards, an idea circulated quietly. ThreeI Atlast could be a disguised craft, an interstellar traveller hidden inside the skin of a comet. The logic was simple and unnerving. For a civilization capable of spanning stars, the most efficient vessel would not be a gleaming ship built from nothing. It would be a hollowed asteroid, a ready-made fortress already armoured against radiation and micrometeoroids. Inside, one could carve compartments, mount propulsion units, thread power lines through the stone. Outside, a layer of dust and gas could mimic a coma where needed venting controlled streams of carbon dioxide to fake the signature of a comet. To any distant observer, ThreeI Atlast would appear lifeless, ordinary, ignorable. Analysts returned to the spectral data. The carbon dioxide emission from ThreeI Atlast was too clean, too symmetric. Where comets showed chaotic bursts of vapour, ThreeI Atlast produced a balanced halo, an atmosphere held steady by something more deliberate than melting ice. The absence of water vapour became another clue perhaps. ThreeI Atlast was using a single compound for camouflage, a controlled exhale rather than natural sublimation. Simulations showed that with small vents embedded in the surface, ThreeI Atlast could regulate its brightness, its apparent mass, even its thrust, just enough to steer without betraying itself. No public report mentioned this possibility. Still, in archived transcripts, scientists used careful phrasing. Phrases like controlled venting pattern and sustained albedo management appeared in technical summaries, euphemisms that hinted at mechanical precision. The more they studied, the more ThreeI Atlast looked less like a wanderer and more like something maintaining a pose. One researcher compared ThreeI Atlast to a deep-sea creature that glows only when disturbed. Another imagined an ark built long ago travelling under the guise of natural debris to escape attention. In every version, ThreeI Atlast was not an accident, it was a survivor. As the weeks passed, the idea spread beyond private circles. Amateur astronomers noticed that ThreeI Atlast traced a route perfectly aligned with the Sun's magnetic field lines, as if following a map no one on Earth could see. Commentators began calling it the Hidden Hull, a name that merged science with myth. ThreeI Atlast, they said, was not simply visiting, but observing, wrapped in stone, waiting for its next cue. Behind the cautious language of official channels, the pattern persisted. ThreeI Atlast emitted light, not heat. ThreeI Atlast maintained shape against solar pressure. ThreeI Atlast lingered within visibility corridors longer than expected. Whether that was chance or choreography remained the question, but every new image seemed to whisper the same suspicion. If ThreeI Atlast was built to look like a comet, then deception was part of its design. The suggestion that ThreeI Atlast might be wrapped in a deliberate disguise made astronomers return to the pulses with new eyes. The brightness from ThreeI Atlast no longer felt like a background detail, but like a line of script waiting to be read. Teams began to strip away everything that was familiar. They corrected for the motion of Earth, for the spin of the telescope, for instrumental drift, until only the rhythm of ThreeI Atlast remained. What emerged from the cleaned data was not a single beat but a nested pattern. The pulses from ThreeI Atlast arrived in small groups separated by quiet intervals that were not random at all. When one analyst measured those intervals, the numbers sent a chill through the room. The counts between bursts from ThreeI Atlast lined up with a simple ladder: 2, 3, 5, 7. Prime numbers appeared again and again in the timing traced back to ThreeI Atlast. For decades, such sequences had been proposed as a universal way to say this is not nature, this is mind. Skeptics asked whether the pattern came from human systems, from the heartbeat of onboard clocks, or from the sampling cycle of the detector. Those possibilities were tested and peeled away one by one until the residue still pointed toward ThreeI Atlast. Then another anomaly surfaced. During periods of intense observation, when multiple instruments stared at ThreeI Atlast at once, the silent gaps between prime number sequences began to stretch and contract. The change was tiny but consistent, as though the source was adjusting its tempo in response to being watched. No one wanted to say the word aware in an official memo. Instead, they spoke of feedback of a coupled system between observer and source. In late-night conversations, the language grew more personal. Researchers admitted that ThreeI Atlast felt less and less like an object and more like a presence, calm, patient, and faintly responsive. That was the point at which the story of ThreeI Atlast began to slip out of the hands of pure astronomy. Once the timing structure was confirmed, summaries were quietly forwarded to defense networks, to committees who dealt not in wonder but in risk. The light of ThreeI Atlast continued to rise and fall with serene regularity, But on Earth, the pattern had awakened a new kind of vigilance. The next concern would not be what ThreeI Atlast was saying, but how close Atlast would come, and what should be done if the message meant contact rather than coincidence. Once the prime-numbered pulse pattern from Atlast was confirmed, the file did not stay in astronomy alone. The timing report was quietly forwarded through internal channels, moving from research groups into defense networks. Screens that usually watched for missiles and debris began to carry a new track labeled simply as an interstellar object. To the people who monitored near-Earth space for a living, ThreeI Atlast was not a romantic visitor. ThreeI Atlast was a trajectory that crossed orbital highways and satellite constellations, a moving unknown with a clock-like heartbeat. Protocol required that anything with that level of uncertainty be treated as a potential risk, however remote the danger seemed. So the orbit of Atlast was folded into simulations used by agencies that rarely spoke in public. Among those tools was a small winged spacecraft that had circled Earth in secrecy before. The X-37B, a robotic spaceplane belonging to the United States, had always been an object of speculation in its own right. Officially, the craft tested reusable technologies and carried classified payloads. Unofficially, many suspected that the plane was designed to watch, to listen, and if necessary to intervene. When new orbital elements for ThreeI Atlast were filed, the path of the X-37B quietly changed. Tracking data available to hobbyists showed the spaceplane drifting from one inclination into another, slowly reshaping the ground track. Over weeks, the motion of the craft settled into a pattern that brought the vehicle again and again beneath the corridor where Atlast would appear brightest in the sky. From the perspective of Earth, X-37B became a shadow following the shadow of Atlast. Classified sensors began to focus. While public telescopes struggled for clarity, specialized instruments riding aboard the spaceplane tuned themselves to the glow of ThreeI Atlast. They recorded not only brightness but polarization, subtle shifts in color, and the way the light scattered in different directions. In that data, analysts saw hints of something strange. The halo around ThreeI Atlast sometimes shifted in ways that did not match solar angles, as if Atlast were shaping the way it wished to be seen. On the ground, these results did not appear in press releases or conference talks. Instead, the presence of ThreeI Atlast was converted into alerts, risk matrices, and closed-door briefings. The interstellar visitor became an entry on security dashboards, glowing softly among many other tracks in low Earth orbit and beyond. Yet even within those guarded rooms, people were still human. Some stayed late after a shift, watching the thin line that marked the path of ThreeI Atlast as the days slipped by. Some imagined Atlast as a distant lantern gliding above the atmosphere, while a silent escort traced loops below. The closer Atlast drew to the inner system, the more one quiet decision shaped the story. Defense would watch closely, perhaps closer than any observatory, but what the wider world would see of Atlast would arrive filtered, partial, and strangely faint, as if a veil had been drawn between public images and the true face of the traveller. The first official images NASA released of ThreeI Atlast were meant to reassure everyone that the visitor was under control. Instead, the frames felt strangely unsatisfying, like looking at a street lamp through fog. On screens around the world, Atlast appeared as a soft smear of light, a vaguely elongated glow with no sharp heart. Engineers pointed proudly to the Mars Reconnaissance Orbiter, whose high-rise camera had captured the best close-up of ThreeI Atlast. The caption announced a nucleus no larger than 3.5 miles, across a neat number that suggested precision. But when astronomers zoomed into the image of Atlast, the brightest pixel looked more like a blur than a solid core. The boundary between coma and nucleus was dissolving, leaving Atlast half object, half haze. In one processed frame, a short tail from ThreeI Atlast seemed to point toward the sun, a sunward-facing plume that could be interpreted as a clear structure. Yet the surrounding glow of Atlast was noisy and unresolved, as if the detail had been sanded away by compression and distance. For a space agency with billion-dollar hardware and decades of experience, this was supposed to be the definitive portrait. What the world actually saw of ThreeI Atlast looked closer to a guess. Researchers tried to extract more from the data, stretching contrast, filtering noise, sharpening edges, but the detail of Atlast refused to emerge. The nucleus of ThreeI Atlast remained a suggestion, not a shape. Outside official channels, people began to ask why a nearby planet could be mapped in exquisite detail, while this luminous visitor stayed so featureless. That quiet dissatisfaction became the first hairline crack in the narrative, a subtle invitation to look elsewhere for a clearer face of Atlast. The next wave of observations would not come from flagship missions but from backyards and small domes scattered under dark skies where different eyes would try to resolve what NASA could not. Not long after the first release, another puzzle emerged from the images of ThreeI Atlast. In one official frame, a short bright tail from Atlast clearly seemed to reach toward the sun, a plume that looked sunward and tidy, easy to label and explain. In others, the faint extension behind Atlast pointed the opposite way, trailing outward as any ordinary comet tail would. Analysts lined the frames up side by side. Using the same reference stars, they checked orientation timing and geometry around ThreeI Atlast. If the sun was here, why did the tail of Atlast lean this way in one set and that way in another? Was the bright streak even part of Atlast at all, or a processing artifact layered on top of the light? The official notes treated ThreeI Atlast as straightforward. Size a few miles across, behaviour comet-like, images sufficient for classification. But behind those thin lines of text, the visual story of Atlast refused to stay consistent. The shape and direction of the tail shifted from instrument to instrument, from release to release, leaving ThreeI Atlast looking less like a single physical object and more like a collage of interpretations. Some scientists argued that changing perspective and timing could explain everything. As ThreeI Atlast moved, the combined effects of viewing angle, solar wind, and scattered light might produce seemingly contradictory tales. Others quietly pointed out that such explanations depended on very specific assumptions and still did not fully account for the mismatch in brightness and sharpness around Atlast. Outside, the agency's amateurs began to study the same regions of sky. From backyards and small observatories, they caught ThreeI Atlast with longer exposures and simpler processing. Their images of Atlast showed a clearer, more stable tail structure than the expensive platforms in space had produced. That contrast fed an uncomfortable feeling that somewhere between raw photons and polished releases, the behaviour of Atlast was being blurred. The next step would be to ask what kind of environment surrounded ThreeI Atlast, and why that environment seemed to resist the labels being placed on it. Around ThreeI Atlast there was more than light. There was an invisible sea. When ultraviolet sensitive instruments focused on ThreeI Atlast, the visitor flared into sharper relief. Instead of a cold, simple glow, Atlast showed a bright envelope of energized gas radiating in wavelengths the human eye could never see. One spacecraft tuned for high-energy photons recorded a distinct cloud of hydrogen wrapped around ThreeI Atlast, a shell of fragments torn from molecules and set adrift. Hydrogen halos like this are the fingerprints of ionization. They appear when intense radiation strips electrons from atoms, turning neutral gas into plasma. Around ThreeI Atlast, that plasma was not a thin veil. The readings suggested a rich layered environment, as though Atlast was sailing through a luminous fog that ThreeI Atlast helped to create. In technical summaries, the term coma stood in for this complexity. Charts listed brightness, particle density, and emission lines near Atlast. But one detail kept slipping through the cracks of public explanation. Plasma dominated the immediate surroundings of ThreeI Atlast. Charged particles flowed away from Atlast, meeting the solar wind, bending and twisting in response to unseen electric and magnetic fields. Some researchers quietly noted that such a plasma sheath could influence the apparent motion of ThreeI Atlast. Interactions between charged gas and the solar wind could generate subtle forces nudging the path of Atlast, or shaping the tails that telescopes captured. In that view, ThreeI Atlast was not just a solid body moving through space, but the core of a dynamic electrical system. Others wondered if the dense controlled carbon dioxide around ThreeI Atlast was feeding this process, providing material that could be ionized on demand. If so, Atlast might be wrapped in a kind of adjustable cocoon, turning solar radiation into a means of control rather than a threat. In the quiet of late nights, as data scrolled past dim screens, plasma stopped being an abstract concept. Plasma became the living weather around ThreeI Atlast, a shimmering invisible atmosphere that reacted, flowed, and sometimes defied expectation. The next datasets would not only track where Atlast was, but how that restless environment moved with it. Those images captured by a mission designed to watch the solar wind would deepen the mystery of Atlast instead of resolving it. The mission, called Punch, was designed to trace the faint breath of the solar wind, not to solve mysteries. Yet when its cameras swept past the region where ThreeI Atlast glided, something unexpected flickered in the composite video. A pale filament stretched from Atlast toward the sun, a stubby tail short and clear. For a few frames, ThreeI Atlast looked like a proper comet again. but the context of that image turned strange the moment the video looped. In the same sequence, the nearby disk of Mars appeared pixelated and uneven, its surface flattened into digital noise. The small moving point of ThreeI Atlast, however, showed sharp contrast-defined edges and visible structure. Analysts watching the playback frowned. Mars was a bright, well-mapped planet, far larger and closer than Atlast. How could the red world dissolve into squares of static while a distant fragment like ThreeI Atlast remained crisp? The official explanation cited processing artifacts and calibration issues between frames. Compression algorithms, they said, had smoothed Mars while enhancing the dynamic range around the dimmer target of ThreeI Atlast. Still, to many who reviewed the raw sequence, the balance felt inverted, as if the data pipeline had decided what should be clear and what should remain hidden. The punch imagery left ThreeI Atlast gleaming in motion, while nearby reference objects blurred away. Among independent observers, the moment became symbolic. The cosmos had granted one of its smallest travellers unexpected clarity and taken it from a neighbouring planet. ThreeI Atlast, it seemed, refused to be lost in noise. Even through layers of filters and compression, the traveller kept reasserting its presence, a tiny beacon more defined than the world beside it. While space agencies released compressed filtered snippets, a different kind of image of ThreeI Atlast began appearing online. They did not come from billion-dollar probes, but from small observatories on hillsides, school rooftops, and quiet backyards. Under dark skies, amateurs pointed their modest telescopes toward the faint path of ThreeI Atlast. Stacking long exposures, they watched as the glow of Atlas separated into a compact core, a clear tail, and delicate streams of material. Where official images turned ThreeI Atlast into a soft blur, these independent frames showed a sharp, narrow spine of light and multiple jets branching away. From Spain, from Chile, from rural North America, different setups locked onto ThreeI Atlast night after night. Despite varied equipment and processing styles, the shape of Atlas stayed remarkably consistent. A bright condensation, a defined tail, and repeating jet structures at similar angles. Each new photograph of ThreeI Atlast seemed to confirm the last-like witnesses, giving matching descriptions of the same distant traveller. In comparison, the institutional portraits of ThreeI Atlast looked strangely thin. The spacecraft views of Atlas showed vague halos, uncertain cores and tails that shifted direction from one release to the next. Yet the amateur catalogue of ThreeI Atlast built up a steady, coherent identity clear enough that even casual stargazers could trace the form. For many watching from the outside, the contrast felt like a quiet inversion of authority. ThreeI Atlast, when seen through humble optics and patient routines, revealed more of itself than it did under the gaze of flagship missions. That realization carried its own kind of emotion, a mix of pride, unease, and curiosity, as if Atlast had chosen to show its true face not to institutions, but to the scattered, persistent eyes of ordinary people. The next step would be to ask what kind of being or environment allowed ThreeI Atlast to maintain such structure, and whether that structure hinted at something more than frozen debris. As the amateur images of ThreeI Atlast accumulated, one quiet question began to surface. What if ThreeI Atlast behaved less like a rock and more like a kind of weather? Scientists already knew that plasma could sculpt vast structures around stars and planets. Around ThreeI Atlast, a dense cocoon of charged gas shimmered in ultraviolet and radio maps, responding to solar wind in complex shifting patterns. Instead of a simple coma, the environment of ThreeI Atlast resembled a layered dynamic shell, like a storm frozen in slow motion. Some researchers described this envelope around ThreeI Atlast in clinical terms: ionized outflow, magnetized sheath interaction region. Others, staring at long-time series of the glow surrounding ThreeI Atlast, began to ask whether the plasma itself might hold structure in a deeper sense. The jets, the tail, and the repeating features near ThreeI Atlast sometimes returned in the same orientation, as if a persistent geometry lived inside the flow. From there, a speculative idea emerged almost reluctantly. Perhaps ThreeI Atlast was not only carrying a plasma environment. Perhaps the visitor named ThreeI Atlast was in some meaningful way partnered with that environment, a composite of core and field matter and charge woven into one system. In that view, ThreeI Atlast became a candidate for something more exotic, a plasma bioform in early discussion threads. Life, after all, had always been defined in terms of carbon chains and liquid water on worlds like Earth. Yet around stars and in nebulae, plasma already pulsed, oscillated and self-organized into filaments and knots. The question was whether ThreeI Atlast showed a level of order that crossed some invisible threshold from pattern to behavior. Supporters of the idea pointed to the way the luminous sheath around ThreeI Atlast reacted to solar gusts bending and reshaping, while preserving overall symmetry. They noted that the pulses from ThreeI Atlast, the prime number spacing, and the subtle orbital anomalies could all in principle be tied to a system that used plasma as both shield and signal. In that picture, the hard core of ThreeI Atlast was only an anchor, while the real organism occupied the charged envelope spread around the traveller. Skeptics remained cautious and grounded. They reminded everyone that plasma loved to mimic intention, forming beautiful deceptive patterns in laboratory chambers with no awareness at all. The data around ThreeI Atlast could still be the natural outcome of fields flows and chance. Even so, during long quiet nights the idea lingered. ThreeI Atlast drifted across the inner system like a lantern wrapped in living fire, a union of stone and storm. Whether that fire around ThreeI Atlast was only physics or something closer to a nervous system remained unresolved. The next chapter of the story would return to more familiar ground, weighing mainstream comet models against these wilder possibilities, and asking again what ThreeI Atlast really was. Long before anyone on Earth knew the name, ThreeI Atlast was already falling toward us from deep interstellar darkness. For millions, perhaps billions of years, ThreeI Atlast drifted between distant suns, tugged only by the weak tides of the galaxy. When the automated survey pipeline finally flagged a faint moving point in July 2025, the software did not yet know that Atlast was different. Follow-up observations quickly revealed how unusual the path of ThreeI Atlast really was. Most small bodies in our skies trace gentle ellipses bound to the sun in predictable loops. By contrast, the orbit of ThreeI Atlast opened outward a hyperbola, slicing through the solar system once and never returning. In the language of celestial mechanics, the excess velocity of ThreeI Atlast was too high for capture, the mathematical fingerprint of an interstellar origin. Astronomers compared ThreeI Atlast with the only two other confirmed visitors of this kind. Oumuamua in 2017 and Comet 2I Borisov in 2019 had already proven that fragments from other systems could wander through ours, yet the brightness, speed and scale of ThreeI Atlast suggested a more massive traveller closer to a small world than a leftover shard. The realization that ThreeI Atlast was the third known interstellar object, and perhaps the largest so far, gave the discovery a quiet weight. Night after night, tracking stations refined the trajectory of ThreeI Atlast. Each new data point tightened the curve, shrinking uncertainty, drawing a precise line that pierced the orbits of Mercury, Venus, Earth and Mars. On navigation screens, ThreeI Atlast became a thin luminous thread threading the inner system, entering from one edge of the sky and exiting through another. The numbers left little room for doubt. ThreeI Atlast had not been born under our sun. Still, some details refused to settle. Small deviations in the motion of ThreeI Atlast hinted at forces beyond simple gravity, tiny mismatches that required extra terms in the equations. Analysts could fit those anomalies with cautious models of outgassing and radiation pressure, but the residuals around Atlast never quite disappeared. In that tension between clean interstellar classification and subtle orbital discomfort, ThreeI Atlast became more than a data point. For those who watched closely, ThreeI Atlast turned into a question written across the sky. Where had this traveller been shaped, and by whom? By random collisions in a distant disk, or by hands and engines we did not yet understand? The next step in the story would not only ask how ThreeI Atlast moved, but whether something about that motion pointed to technology rather than chance. Not everyone was content to let ThreeI Atlast remain a purely natural wonder. Among those who looked more closely, one voice in particular stood out, a familiar figure in debates about interstellar visitors. Avi Loeb, a Harvard astrophysicist known for challenging comfortable assumptions, had already argued that Oumuamua might have carried signs of technology. When the orbital fits for ThreeI Atlast began to show small non-gravitational deviations, Loeb recognized a familiar signature. The equations required an extra push, a gentle acceleration or braking, that did not line up cleanly with the amount of gas telescopes saw escaping from ThreeI Atlast. In Loeb's language, that imbalance hinted that something beyond ordinary outgassing could be at work. Loeb walked through the numbers in his usual methodical way. ThreeI Atlast appeared larger and more massive than previous interstellar visitors, yet the observed change in motion was subtle and directional. If ThreeI Atlast released only modest amounts of gas, that release should have produced a diffuse, uneven effect. Instead, the trajectory of ThreeI Atlast suggested a quiet, sustained correction, as though thrust were being applied with care. From there, the hypothesis unfolded. If a distant civilization ever sent probes between stars, those probes would need efficient propulsion and stealth. A hollowed body like ThreeI Atlast Loeb suggested could hide engines behind a screen of dust and CO2 using controlled venting to adjust course. In that framework, the prime number pulses and the precise corridor of visibility turned ThreeI Atlast from passenger into pilot. Loeb did not claim certainty. He framed ThreeI Atlast as a question, not a verdict. Extraordinary claims, he reminded readers, demanded extraordinary evidence. Yet Loeb insisted that refusing to consider technology at all would be a different kind of unscientific. If nature could explain ThreeI Atlast better, data would show how. If nature could not, ThreeI Atlast might become the first quiet sign that the galaxy had been sending emissaries past our door for longer than anyone realised. The community's answer would be to gather more light from ThreeI Atlast and to let the spectra themselves argue back. While theories about alien engineering circled in late-night conversations, the mainstream gaze turned back to the light from ThreeI Atlast. The question was simple and quiet. If ThreeI Atlast were only a comet, the spectrum should look like countless others before. Hubble turned toward the visitor, spreading the glow of ThreeI Atlast into bands of colour finer than any human eye. Within that rainbow, Hubble found the familiar fingerprints of a classic cometary coma around ThreeI Atlast water vapour, carbon dioxide and dust reflecting sunlight. Lines from common molecules rose gently from the background, telling a story of ices warmed by the sun and lifted away from Atlast grain by grain. To many observers, the chemistry around ThreeI Atlast sounded like an old song played on a new instrument. SphereX, a mission built to map the sky in infrared, added another layer to the picture of Atlast. By measuring how ThreeI Atlast absorbed and re-emitted light across many wavelengths, SphereX traced the distribution of volatile material around the traveller. The data showed reservoirs of frozen gases and complex organics, the kind of ingredients long associated with comet nuclei rather than manufactured hulls. In report after report, the environment of ThreeI Atlast slotted neatly into well-tested models of natural comet behaviour. For the mainstream community, this was comforting. If Hubble and SphereX both saw the same chemistry, then ThreeI Atlast could rest safely inside the category of interstellar comet. Papers described ThreeI Atlast as valuable, unusual, even historic, but still at heart a natural body following known physical rules. Yet a small tension remained at the edges of that calm. The orbit of ThreeI Atlast still carried those faint non-gravitational nudges, and the earlier prime number pulses did not vanish from memory. The light from ThreeI Atlast, apparently ordinary in composition, still pulsed with an order that seemed to ask for interpretation. As the evidence for a natural origin grew stronger, the story of Atlast did not close. Instead, the narrative shifted to a new question: how much mystery could remain inside a comet that looked on paper so reassuringly familiar? The next signals to be examined would come not from reflected sunlight, but from longer, quieter radio waves reaching Earth from the path of ThreeI Atlast. The quietest signals in the story of ThreeI Atlast arrived not in light but in radio waves. In early November, the Meerkat Array in South Africa detected a narrowband emission coming from the direction of ThreeI Atlast, a whisper, at a frequency historically associated with interstellar chemistry. For a few days, headlines and forums filled with a single question was ThreeI Atlast sending messages across the void. When the data were examined closely, the line matched a familiar transition from hydroxyl radicals, OH, produced when ultraviolet light breaks apart water around a comet. In that interpretation, ThreeI Atlast behaved exactly as a rich active comet should, turning sunlight into radio signatures that astronomers had catalogued for decades. Reports emphasised that this was natural master emission, not a modulated beacon, and the excitement around ThreeI Atlast briefly receded. Yet the explanation did not erase every doubt. Avi Loeb and others pointed out that a technological probe could still carry a shell of ice and dust, allowing ThreeI Atlast to mimic comet chemistry while hiding a different interior. In that view, the OH line from ThreeI Atlast confirmed only that water and radiation were present, not that the traveller was purely geological. The sky offered no clarification. ThreeI Atlast continued on radio quiet at other times, leaving behind a single detection that fit models perfectly, and yet still brushed against the earlier prime number pulses. For those following the narrative closely, the radio episode became another layered note in the song of ThreeI Atlast comforting on the surface, discordant underneath, pushing the story toward the more visual mysteries that followed in the changing colours and tales. The changes in colour were the first thing that made even veteran comet watchers fall quiet, at a comfortable distance from the Sun 3. Atlas glowed a deep rusty red, as if its surface had been baked for ages by cosmic rays. Then as sunlight began to work deeper into the skin of ThreeI Atlast, the hue shifted. Filters showed a soft green emerging around the head of ThreeI Atlast. Spectra linked that glow to carbon-based fragments. Molecules lit up as they were stripped and recombined in the coma. Soon after, as ThreeI Atlast drew closer, still a cooler blue tone appeared in deeper exposures associated with ionized gases and more volatile ices. It was as if ThreeI Atlast was peeling back its own layers, letting each shell of its history shine in turn. At the same time, the geometry around ThreeI Atlast grew more complex. Observers saw not one tail but several slender plumes fanning away from the core of ThreeI Atlast. On some nights, a bright spike seemed to point almost toward the sun, an anti-tail that defied simple pictures of dust blowing outward. Models showed that perspective alone could create such illusions. Seen from just the right angle, the dust sheet behind ThreeI Atlast could line up with our view and appear to point inward. Yet knowing the explanation did not make the sight less uncanny. ThreeI Atlast looked less like a tidy sketch from a textbook, and more like a shifting sculpture of light and dust. For many, the changing colours and tangled tails made ThreeI Atlast feel alive in a way numbers could not convey. Each new configuration invited fresh questions about what forces were shaping the traveller. The next focus would fall on how ThreeI Atlast survived its closest brush with the Sun, and whether that encounter left another subtle signature in its path. When ThreeI Atlast swung around the Sun, most astronomers expected disintegration. Instead, ThreeI Atlast emerged whole, glowing sharply in post-perihelion images. The violent heat had stripped its outer dust but left a dense, intact core. Tracking software recalculated the orbit of ThreeI Atlast using new coordinates. The fresh curve missed predictions by a few arcseconds, small but real. Some teams attributed the shift to uneven jets venting from the surface of Atlas during perihelion. Others saw a different pattern, a deviation too clean to be random, hinting at controlled adjustment. Whatever the cause, the message was the same: ThreeI Atlast had survived the fire. The visitor had endured pressures that destroyed countless comets before it, and yet ThreeI Atlast continued outward, silent, precise, and subtly off course, as if leaving behind a final, deliberate signature in its wake.